Hello, this is Ruby Insights, a channel dedicated to software engineering, architecture, best practices, and the tools that truly make a difference in professional development. If you are looking for technical clarity and a strategic vision of programming, subscribe to the channel and hit the bell to follow our upcoming content. Ruby Insights, engineering beyond syntax. Let's get into today's video.
In March 2026, the Ruby ecosystem split into two distinct tracks, forcing immediate architectural changes for enterprise applications. The first track involves an urgent security lockdown. Maintainers released patches for the Ruby 3 and 4 series, alongside simultaneous updates for Ruby on Rails versions 7 and 8. These releases follow the disclosure of CVE-2026-27820, a buffer overflow vulnerability in the core Zlib library. CVE stands for Common Vulnerabilities and Exposures, a standardized list of publicly known cybersecurity flaws. This was identified alongside 10 framework-level vulnerabilities, including cross-site scripting and resource exhaustion vectors. Simultaneously, the rollout of Ruby 4.0 has introduced a structural shift in how the interpreter handles memory and concurrency. Organizations are now navigating the limitations of legacy infrastructure while evaluating a modern runtime engineered for greater robustness. The Ruby support lifecycle matrix shows that the maintenance window is narrowing. Ruby 3.2 has reached its end of life. Ruby 3.3 moves into a security-only phase, while 4.0 remains the full maintenance target. Because the 3.2 line terminates completely on March 31, 2026, teams must immediately audit production stacks. Ruby 4.0 replaces optional syntax updates with a mandatory structural shift in the underlying runtime. Pinning an application to an older runtime increases risk. As the entire GEM ecosystem moves forward, unpatched versions lose access to performance improvements and critical security updates. Maintaining secure enterprise applications requires navigating this transition before legacy dependencies move beyond the reach of official patches. The disclosure of CVE-2026-27820 within the core Zlib gzip reader component exposes the structural risks of the legacy C extension model. Zlib handles HTTP compression and asset management for nearly every Ruby-based web stack, making this vulnerability a high-priority threat for millions of applications. The flaw is in the C extension prepending caller bytes to existing output. Zstream buffer ungets doesn't verify the backing string's capacity before a memmove operation copies memory blocks. When prepended data exceeds capacity, the operation overruns the array and corrupts adjacent memory. This memory corruption allows an attacker to bypass the interpreter's safety guarantees, leading to immediate process termination or arbitrary code execution via overwritten function pointers. Framework-level vulnerabilities discovered in Rails 8 show similar patterns of resource exhaustion. In active support, remote attackers can submit scientific notation strings that the BigDecimal component attempts to expand indefinitely. This triggers a CVE-770, a specific vulnerability involving the allocation of resources without limits, which can crash the server. Active storage faces a similar vector where unconstrained HTTP range requests force the server to perform excessive, paralyzing disk input and output operations. These vulnerabilities reveal the inherent fragility of relying on unmanaged memory and unconstrained allocations. Ruby 4.0 introduces architectural primitives to resolve these execution bottlenecks. The first addition is a new strategy for the just-in-time, or JIT, compiler pipeline. A JIT compiler translates program code into machine instructions during execution to increase performance. This diagram compares two JIT strategies. On the left is YJIT. It compiles small chunks of code on the fly, specializing them based on runtime data types. On the right is ZJIT. This new parallel compiler is designed to raise the language's long-term performance ceiling. ZIT processes larger units of code using a traditional method-based compilation strategy. It translates large method blocks through a static single assignment intermediate representation. SSA assigns variables exactly once, allowing more advanced optimizations before outputting optimized machine code. This new pipeline is currently opt-in and requires Rust 1.85 to build. To maintain production stability, YJIT remains the default compiler for most workloads. Developing two distinct compiler pipelines simultaneously allows the language to preserve reliability while engineering for higher execution speeds. Ruby 4.0 also introduces structural isolation at the language level. Historically, Ruby processes share a single memory space. Constants, classes, and C extensions can interact freely, leading to global state bleeding between different parts of an application. RubyBox provides a solution for in-process containerization. As seen here, the current model allows internal components to mix freely. Creating a RubyBox establishes a walled-off environment. Loaded libraries and classes are confined, preventing internal state from leaking into the wider process. This primitive enables smarter code loading and provides a foundation for secure, multi-tenant architectures. Concurrency has also matured through improvements to ractors. Ractors are isolated execution contexts that allow Ruby code to run in parallel on multi-core systems. To improve usability, maintainers removed the older yield and take mechanics that previously complicated communication between contexts. Now, Ruby 4.0 introduces the ractor port, which serves as a robust channel mechanism for safe, bidirectional data exchange. These updates reduce shared state and lower contention points, allowing the runtime to utilize multi-core CPU caches more efficiently. RubyBox and ractor ports limit the blast radius of memory errors, shifting the language toward an architecture of isolated, parallel execution. These technical shifts define the immediate requirements for engineering teams in early 2026. Support for Ruby 3.2 has ended, and Ruby 3.3 will no longer receive patches for non-security bugs. Patching a legacy application's Zlib dependency to version 3.2.3 triggers a cascade through the dependency tree. This requires newer toolchains, like Bundler 4, which locks out legacy runtimes, moving the application to a zone requiring Ruby 3.4 or 4.0. Teams must immediately audit their production stacks to verify the status of the Zlib patch. If legacy code prevents a full runtime upgrade, the Zlib gem must be updated explicitly via the dependency manager as a short-term mitigation. The long-term strategic requirement is a comprehensive migration to Ruby 4.0. Pinning to older versions creates a false sense of security. It merely accumulates compounding structural debt that makes future upgrades significantly more difficult. Standardizing on Ruby 4.0 aligns the application with a hardened runtime designed for secure, multi-tenant execution.